Part 3. The limit of perception. This brings us to a crucial distinction, the difference between the universe and the observable universe. When we say the universe is 13.8 billion years old, it means we can only see objects whose light has had time to reach us within that period. This is our boundary, the particle horizon. It is not a physical wall, but rather a temporal horizon. We see distant galaxies not as they are now, but as they were billions of years ago. And because the universe has been expanding this entire time, that galaxy whose light traveled for 13.8 billion years to reach us is now located approximately 46.5 billion light years away from us. This makes the diameter of our observable universe approximately 93 billion light years. What lies beyond this horizon? We cannot see, but we can hypothesize. If we follow the cosmological principle, the idea that the universe is homogeneous and isotropic, the same in all directions on large scales, then beyond the horizon lies simply more universe, more galaxies, more clusters, more voids. But if the theory of inflation is correct in its more radical form, known as eternal inflation, the picture becomes even astounding. This theory suggests that inflation, having stopped in our pocket of space, creating our universe, continues eternally in other regions of metastasis. This process endlessly generates new bubble universes, each of which may possess its own fundamental laws of physics. In this scenario, our universe is merely one island in an infinite archipelago of the multiverse. Part 4. The philosophical horrors of infinity. The idea of an infinite flat universe, or an infinite multiverse, has profound and disturbing philosophical consequences. If space is infinite and contains matter, then every possible configuration of particles must be realized within it. This means that somewhere out there, at a distance beyond all imagination, an exact copy of you exists, listening to this narration. A copy exists who is making a different choice. An infinite number of your copies exist. But there is a paradox that goes even further. This is the Boltzmann Brain paradox. It states, if the universe exists for a long enough time, especially if it is heading towards a heat death of maximum entropy, then over an infinite duration, random quantum fluctuations can generate anything. Statistically, it is far more probable for a single conscious brain, a Boltzmann brain, to spontaneously fluctuate into existence from chaos, perceiving itself and its surroundings for just a moment with false memories of a past, than it is for the entire low-entropy universe we observe, with its billions of years of orderly evolution to arise from chaos. If we live in an infinite universe, why should we be confident that we are the products of a long evolution, and not just a random fluctuation doomed to vanish in the next instant? This paradox calls into question the very nature of our perception and the reliability of our existence. Part 5. The eschatology of the cosmos. The final choice. The question of spatial finiteness is inextricably linked to the question of temporal finiteness. What is the ultimate fate of all that is? Until recently, two scenarios dominated. The first is the Great Heat Death, or Big Freeze. This is the scenario that follows from the accelerating expansion of the universe we observe today. The driving force, dark energy, acts as a cosmological constant, pushing space apart ever faster. Galaxies will recede from one another beyond the horizon of visibility, stars will extinguish, black holes will evaporate via Hawking radiation. The universe will devolve into a cold, dark, dead desert of maximum entropy where nothing can ever happen again. Eternal nothingness. The second scenario is the Big Crunch. This is the fate of a closed universe where gravity eventually wins. The expansion stops, reverses into contraction, and the entire universe collapses back into a singularity, perhaps giving birth to a new Big Bang in an infinite cycle, the Big Bounce. For decades, the heat death seemed to be our inevitable end, but recent observations of dark energy have once again shaken this certainty. Some new models, analyzing data from quasars, suggest that dark energy is not a constant. It may be weakening. According to one such model, dark energy is a field that loses its strength over time. If this is true, then in approximately 11 billion years, the expansion will reach its peak, and then gravity will take over. The universe will begin to contract. This process will last for about 8 billion years and will culminate in the Big Crunch, a Big Bang in reverse. The total lifespan of our cycle of the universe would be about 33 billion years. Conclusion. So does the universe have an edge? No physical wall exists. There is no outside to point to. But we are surrounded by boundaries of a different kind. We are locked within the observation horizon, a bubble of visibility limited by the age of the cosmos. Geometrically, our universe appears flat and infinite, which throws us into the vortex of philosophical paradoxes, of infinite copies and phantom Boltzmann brains. And perhaps we are limited in time. We may be just one episode in an eternal cycle of cosmic birth, death, and rebirth. The edge of the universe